We are looking at question 27 of 2018 HSC Engineering Studies. We have a diagram here. Forces RA and RB at supports are acting on that, and also we have loads 15 kilonewton and 12 kilonewton respectively. Each division is 1 meter, and they need us to draw the shearing diagram and also the bending moment diagram. The first step for us to find the value of RA. To do that, we can take the moment around RB, bending moment around RB. That will be RA times 6, because RA is 6 meters away from this point. And this is in clockwise direction, but 15 kilonewton and 12 kilonewton will have a moment in anti-clockwise direction. So we need to take them away. So RA times 6 minus 15 times 4, because 15 kilonewton is 4 meters away, and minus 12 times 3 equal to 0. So the moment here must be 0. Or moment at any point for the sake of this discussion, because the whole system is in balance or equilibrium. Alright, solving this equation, you get 6RA minus 15 times 4, 60, minus 12 times 3, 36. Taking them to the right hand side, you get 6RA is equal to 96, and then dividing both sides by 6, you get RA equal to 16 Newton, 16 kilonewton. To find RB, we can use the total amount of forces must be equal to 0. The forces acting down must be equal to the forces acting up. So RA plus RB is equal to 15 plus 12, and that gives us 27, and because RA is already 16, so RB will be 27 minus 16, which is 11 kilonewton. Now we find both forces, RA and RB. We are in a position to draw the diagram they are asking. Starting from the left, the only force acting is RA, which is 16 kilonewton, and this force keeps acting until the next force, which is 15 kilonewton, comes in, and then this reduces it to 1, because 16 minus 15 is 1, so this is 1 kilonewton shearing force. So shearing force from here to this point, which is the point of application of 15 kilonewton, is 16. Then from 15 kilonewton onwards, it becomes 1. Then we have the next force, which is 12 kilonewton. And from 1, if you take 12 kilonewton, becomes minus 11. So we have a shear force of minus 11, which is in opposite direction to what we had. So far, it was the shearing force was up, now the shearing force is down. For the moment, starting from the left hand side, we have 16 kilonewton times 2 that peaks here. That gives us 32. So that should be 32. This height is 32 kilonewton meters. Then when the other force, the 15 kilonewton, comes in, it takes away some of the moment because it's in opposite direction. So still the moment is growing, but at a lower rate because 15 kilonewton provides a moment in opposite direction. Then to find how much moment we have from at that point, we see it is 16 kilonewton is 3 meters away from that. Take away 15 kilonewton, which is acts here, is only 1 meter away from that. And that gives us 33 kilonewton. So at that point, we have 33 kilonewton meters. And then when the third force comes in, now we start the reduction in the bending moment. And we know that at the end it must be equal to 0. Because from here onwards there is no force and the system is in equilibrium, so the moment here will be 0. That is all for this lesson. Thank you for your attention.